Okay, so this is going to be another tutorial on using Ocean Data View, ODV, to, in this case, plot up sections of data. So this is basically a vertical slice through some part of the ocean. So we can plot up kind of some parameters that we've got measurements of, say maybe a section of oxygen concentration or temperature, and see how the ocean is basically layered up with respect to that. So hopefully you've seen before the video on producing a temperature and salinity plot like this up here. We should be fairly comfortable making simple section plots like this. And I should point out at this stage that while section plots like this, so these are station plots, these are section plots. So station plots can be very kind of visually kind of eye-catching and can be very useful to pick out certain features in the water column. They can also hide quite a lot of detail, so sometimes it might be better to use a very simple station plot like this to see some of the fine detail in a data set, rather than something that maybe kind of looks a little bit more fancy. But you need to decide what it is, the thing that you're trying to show, and then try and decide the right kind of plot to demonstrate that. So before we start, I'll just also point out a way in Ocean Data View to save these plots so you can come back and work on them later. So you can have, say, multiple kind of all of your figures in Ocean Data View and kind of modify them one at a time. You don't need to kind of save the final image and then you can't go and alter that again. It's very also useful so you don't kind of lose any kind of work you've done. So once you've kind of got a figure that you kind of are maybe halfway through working on or are happy with, you can save that by using this view up here, and you can save the view as, and then that will bring up a little dialog. So this will appear in the folder of your kind of like data that you've created when you created the ODV collection, and you just give that some name. So sections from Oban. And you can then save that. So that's not saving the image that you've created, that's effectively just saving the sets of instructions that will look in that data file or that ODV collection and create this plot. Okay, so it's very useful so you can then come back and alter this figure later. So I'll just start out with a very simple, so you might start out with a, you might have, for instance, X-ray. You might have some data plotted up that's maybe oxygen like this, and you might have played around with your data to produce a number of station plots like this, but you might want to plot a section. Okay, so the first step to doing that is to basically play around with the window layout to change the plot that you have to one that is a station plot. So that's going to be something that plots depth, but instead of on the horizontal axis here plotting some parameter, we want to plot distance, either longitude, latitude, or the distance along a profile. Okay, so to do that, you can right-click on the background, and you get a layout templates. So we've got, I'll just do that over here, so it's in the middle of the screen. Layout. So we've got a station window up at the moment. Scatter plots are what we used for the temperature salinity plot. And the one we're going to do now is a section plot. So we're just going to click one section, and this now is plotting up depth against section distance. Now I already have a section defined, but when you do this for the first time, this kind of the data in this window might not come up. You might not have the bathymetry. So the first thing you have to do is define a line through your data points that your section is going to be kind of plotted along. So to do that, right click on the map down at the bottom, so right click, it says manage section. You can define the section. Okay, and this brings up a map of your data points, and then you can basically click at the beginning, click through all of your data points like this. Now you can alter the width of which the section will include data, so you can see this data point here is just outside of our section box, so it won't plot that data point. So we could maybe make our section a bit wider, so make this 1.5 0.15 kilometers, and you can see that's made that envelope a little bit wider. And I'm going to plot bottom depth as the bathymetry. So if you click no bathymetry, then it won't plot that kind of black thing to show us where the bottom of the lock is. If we use the bottom depth, that'll use basically the value in the ODV file for the bottom at each station. Alternatively, we could have a file that has the bathymetry in. We don't have that for locative, but you could do that if you had that. But we don't, so don't do that. We could give our section a title, and this will be useful so that we can come and kind of recover it later if we wanted to do multiple sections through slicing through the data in different ways. But for most uses, you'll just have one section. We'll call this Alex's section. Okay. It might be, I don't know if we can have apostrophes. See if that works. You can change the bathymetry color if you want to. Let's have that as, I don't know, something horrible, pink for no reason. And then when you plot it up, you'll get this section through like this. I'll just go back and change that because that's a hideous color. So to change the properties of that section, okay, we go to manage our section, okay, and then we go to section properties, and then we bring that back to this window here, and we can have something a little bit more sensible. Okay, and that changes it to a nice brown because mud is brown. You don't have to have brown. I'll just get rid of these grid lines because I have an irrational hatred of grid lines where they don't help. Now, sometimes you'll do a plot like this and the bathymetry won't show up. So this could be for a number of reasons. So the first of all is that you need your depth to be the primary variable in your ODV collection. So if we go to our collection up here, we could go to identify key variables, and we need to make sure that the key variable depth in the water column is associated, if we click on that, is associated with depth in the in our collections here. So if we remove that, okay, and then we make this plot. So if we go, let's cancel that. If we choose it to plot something, say salinity, okay, you can see that the bathymetry doesn't show up now because we don't have depth associated with depth. So if we go to okay, go to general. Okay, so we first of all, go back. So sorry. So the if we go to properties, general, we need to make sure that our primary variable is in fact depth. Okay, and then we also need to make sure that it knows that that primary variable depth is actually depth in the water column. It could just be that we've got a variable that's called depth, but we've got to associate that so ODV knows what it's looking for. So identify key variables, look for depth in the water column, associate that with depth, associate, you can see the star appears, click OK, and now if we do another plot, maybe press Z, that brings up the Z variable window, so that's the same as right clicking and then going to Z. Okay, change that to wet star, which is fluorescence. You can see now that it's changed the data it's plotting up, and it's given us some nice bathymetry. Okay, so that's how to create a section plot, and you can go in and change how it's plotting the data. At the moment, it's just plotting the data points down each section, so we could change the way that appears. If we right-click on the plot, go to Properties, go to Display Style, so we can have the original data, which is what we're plotting at the moment, or we could get ODV to do some kind of gridded averaging. Okay, so you might want to think carefully here about how you scale the smoothing between the X smoothing and the Y smoothing. So basically we don't have, I'll just click go with the automatic here. So that's basically smoothed in the data, well, smoothed in what it thinks the data is between all of our points. So if we make those numbers big, so if we make these big, this is what this is doing, is this is averaging out more, so this is smoothing out variability. So I'll click OK, and you should see that that's reduced the variability that's visible in this plot. And if we think about how the data is actually kind of available to us. We don't have much resolution in the X direction. Okay, we have 1, 2, 3, 4, maybe 10 or so profiles, but in the Y direction we have many points per profile. So when we set our length scales that we're smoothing over, we should think about making the X scale here maybe big, but the Y scale much smaller, because we have more variability that we don't want to average or smooth away with that. So if we bring that back, we can now maybe see a little bit more structure in our data sets. So one thing you want to be cautious about when you're doing sections is how you smooth the data. Okay, so that's one thing that you want to think about. Other things you want to think about, you also do need to show, so you can see here these black lines. So if we go to properties, you do need to make sure that the data is being drawn. Okay, so you make sure that this box is ticked down here, because that shows you where your data actually is from. So if we click OK there, so that tells us that in this region here we can't actually be that confident about what the values are, but over where the data is we are more confident. Okay, so that's one thing that you should be able to make plots now. I'm just going to show you now some of the ways that we can start to modify these plots to maybe make them useful. Okay, so one thing that you can see on this figure is that actually quite a lot of the variability is up towards the top of the diagram, so we might want to think about adjusting the scale, so we can go into here and then set ranges. Okay, and we can set the X, the Y, and all that kind of stuff. So we can maybe set that to 15 meters in the Y direction from 0 to 15. OK, and now we've basically zoomed in on the top part of the water column, and we can see some of this variability a little bit more clearly. So that's one thing you might want to think about. Another thing you might want to think about is putting a plot on top of the plot that we have at the moment. So we've got one variable being shown here, so the fluorescence, but we might want to compare the fluorescence to another parameter. We might want to worry about, is this where temperature changes or salinity changes? So one thing we can do is we can overlay some contours of another parameter on top of this plot here. So I'll just show you how to do that, and to do that we have to go into the window layout tab. So this is useful for kind of making your plots look kind of how you want them to, but it also enables you to put one figure on top of another. So if we go right click off the canvas or on the background here, go to window layout, so this brings up our window layouts tab. So we can do all kinds of things in here. So we could first of all, we can, if you right click on a window, we can maybe move or resize that window. We could maybe move it around, have maybe a smaller section. If you then click enter, that sets that over there. We could maybe move our map around, move or resize our map. Maybe put our map up here somewhere. We can duplicate. We can create another window, and you can do that by creating a new window, or which will create us a new window. I'll just delete that one. But if you wanted another section, the easiest thing to do is to right click on the section and then create new window, and that gives us a new window which we can then move somewhere like that. So this might allow us to then kind of look at maybe two sections next to each other, make it easier to compare. But I was talking a bit previously about overlaying one section on top of the other, so we can see two things on the same plot. So to do that, we just go to create overlay window. So right click on where the window is going to be, create overlay window, and then we have to choose what variable that window is going to plot. We can change this later, but so I might want to compare, say for instance, the salinity of the water against the fluorescence. So we've got wet star fluorescence plotted already. Go for salinity, click OK, and that gives us a second parameter for this effectively window here. So it's basically two windows plotted on top of each other. So if we just click enter now or go to accept, eventually this gives us this, and you can see now that we've got two windows. Okay, so one is this one at the bottom is a duplicate of the one at the top, but this time we've got an overlay of some contours of salinity on top of that. So you can see here that I've slightly messed up and these windows are a bit too close together, so we'll just quickly go back into the window layout, just move that one down a touch, okay, and accept that. That separates them out a little bit. Now if you wanted to change these contours, if you right click on this window now, so now right clicking on this window will only give you control over the contours or the plot that's overlaid. We can still change the window underneath, and I'll show you how to do that in a second. So if we wanted to change the contours, we go into this contours tab in the display properties over here, and these are the contours that it's decided to plot for us. We can highlight all of those and get rid of them if we don't want them. So, but we can see basically we might be interested in the contours around, say, 20. So if we click that, that gets rid of those. Now we can choose in this window that we might want to start our contours at maybe a salinity of 15. We might want those contours to go up to maybe 28, say, and have an increment of every one kind of salinity unit, although salinity is unitless. We might want to change how our lines are plotted, so we might want to be, I don't know, let's say medium. I think it's a good idea to have them in this case in white, because that's a nice contrast to the colour in the background. We might want to go and change that. We want them to be nice and solid. You can have dotted or dashed if you dotted or dashed if you want, and we don't really want to fill the space in between the contours in. You could do that if you wanted to, and then if we click on these left arrows, that creates those contours. Do them. We want to do those contours, and then just click OK, and you see it's now plotted all those contours. So you can see in this case it was a very stupid idea to plot those contours because it's kind of covered up all of the stuff we've seen. So we could then go back, properties, and then highlight all of those and get rid of them. Keep our things again 15 to say 28. Every 2, say, so reduce the number of them. We don't want them to be medium, we want maybe thin medium, and white again. Okay, so that's quite nice. So we can see now that maybe some of this variance in salinity is related to the variance in fluorescence, or the other way around. Okay, so so that's one thing. I mentioned before it might be a good idea for us to think about changing the plot on the background. So if we wanted to change that, we can't get to this plot, this fluorescence plot behind, because every time we right click on this one, we go to properties, it's the salinity one. Okay. So there is another way of getting to the properties tab for this wet star one. We could go to window properties. If we click on the background somewhere, go to window properties. Okay, so it lists all of the windows in our plot here. So there's the map window, there's the window 1, window 2, window 3. So unfortunately it doesn't tell us which ones these are. If you're unsure, you can go into the window layout tab, and this will tell us that this is a map, window section 1, 2, and then the overlay one is window 3. So we can then go to window properties and then window 1, and that brings up the properties tab for the one that we couldn't get access to earlier. So we could, for instance, go to our data here. We could go in and change what it's plotting on the say the y-axis. Okay, so instead of wet star, we could say plot the photosynthetically active radiation. We could change the color bar settings to minimum, maximum, all that kind of stuff, and click OK. And you can see that's changed the background window, okay, without changing the overlay window on top. So that's one thing we can do. I'll just show that again. So we go to window properties, go to window 1. We could maybe change the depth here. We can maybe go back to like that. Okay, so one thing that is slightly annoying about the way that ODV works with sections is that if you have more than one section on a diagram like this, the Y scales, the depths are always the same. So just go to set ranges again, change that back to something a little bit more annoying. Right, so they're always the same, and we can get to these windows at the back without without just clicking on them. We can get to them using this extra way by going to window properties, and it lists all of the windows in our canvas. So we've made some sections. We kind of can compare one section with another by placing them on the same plot. We can use overlay windows. That's quite useful. We can save. So view, save, view as, and then we can give it a new name. And I could call this one something that tells me what it's plotting up. Star. Okay, and then save that, and that saved that window. Okay, so when we're using sections like this, one thing we should also be thinking about is the color scheme that we're using for these windows. So this is quite important because the colors that we can use not only make our kind of plots a little bit easier to interpret than a black and white figure, but you need to be quite careful when you use these, in that sometimes the colors can be a little bit misleading as to where the important variability is. So I'll just demonstrate that with this plot at the bottom here. So I'll change what it's plotting to oxygen. So if I just hover the mouse over the plot, click Z, plot oxygen. So we can see here that we've got some high oxygen near the surface. Actually, the oxygen maximum is just a little bit below the surface. I'm not going to think why that might be. And then we've got a little bit of lower oxygen concentration down at depth here. And one of the things that this plot is quite useful for is that we can see the different kind of oxygen concentrations, different water masses, and we can see that where the changes in oxygen are. So that the thing that you need to be quite careful about is if you use a color scale that's kind of rainbow like this, is that the changes in color, the position that there's a color change, is kind of a little bit arbitrary. Okay, so we can see that there's a strong color change along here and a strong color change along here. So this suggests that the rate of change of oxygen across these boundaries, that we've got maybe uniform oxygen over here and uniform oxygen in here, but there's a sudden change at this point here around where the colors change. Whereas that actually might not be the case. Okay, it might be we just have a gradual change from high to low as we go down in the water column, but that's kind of being obscured by these sudden changes in colour in the colour scheme that we've got here. So it's quite often nice to have kind of visually appealing plots with lots of pretty colours in them, but actually that can mislead you into showing their extra variability where there isn't some. So an important thing for you to think about is to use suitable colour scales when you're making your plots. So to change the colour scale of a plot, very simply, if you right click on it, you can go to properties, and if we then go to general now, we can change the colour scheme over here where it says palette. So ODV palette is this default colour scheme which goes from purple to red, which is slightly garish, and you could change that if you so for instance the MATLAB default is a similar colour scheme, goes from kind of blue to red, but again it kind of maybe looks a little bit less garish, doesn't have the purples in it if you don't like purples, but it still has this feature where it looks like we have this really strong change here and a really strong change here, whereas in fact it might not be so strong. So one of the things we can do is thinking about using simpler colour schemes. So if we go to properties, there are other colour schemes in here which are potentially more simple. So if we just go to blue only, okay, for instance, this shows us that now we've just got a very linear change in colour, and we can now actually see that the gradient across here is perhaps a little bit more kind of spread out than the colour scheme suggested. So that's an important thing to think about when you're making these plots. I would also point out that some of the smoothing out here might be because we're smoothing the data when we plot it. So a thing to check would be to go in, look at the properties, go to the color display style, and we can see that the Y scale here is smoothing out, in this case, to 100 parts per thousand. So basically 10, it's basically smoothing over 10% of it. So this makes no sense. So because we have lots of data in this scale, so if we make that small, so now it's 10 parts per thousand. So basically it's splitting up the Y axis of our section into 100 kind of like discernible kind of units. And we can see now that that's changed. We can see a little bit more structure in here, but we can again see that some of these, where we saw that there was perhaps a sudden change in oxygen, is actually probably not such a big deal. Okay, it's not such a big difference. Do think about using appropriate colors. Do think about using appropriate scales. Okay, so this is another case where you might think about appropriate scale. So this is going to white at about 4 in oxygen concentration. So it might be appropriate to think about, actually, do we want to, depending on what we're trying to show, do we want to show where there are processes going on the upper water column, where we might want to focus in on changing the scale to focusing on up here. So we could perhaps change our scale, go to color mapping, and make the scale kind of change the most at these high values up here. Get some high on linearity, and then we can see actually some much more detail of what's going on in the upper water column here. Or we might decide actually the thing we're trying to show is that the water column does not go to 0 oxygen. So we could maybe plot up the look at the range that we're plotting, so go to set ranges, and instead of going from 4 and a bit to 6 and a bit, we could say go from 0 to 6 and a bit, click OK. And in this case we can see actually we're, well, again we need to think quite carefully. So we've made our color scheme not very linear here, so a value of 4 is indistinguishable in the color from a value of 0. So we could go in our properties, we could click linear mapping again, so we've got a nice linear change in color, click OK, and here we can see that this plot looks almost completely blue. So this is showing us that there's plenty of oxygen throughout the whole water column, only a tiny little bit lower in this region. So do think about changing the scales, both vertically and the color scale, and think quite carefully about whether you're using the right kind of color scale for your section plots. Okay, so I'll just go and save the view as, and I'll change this to blue 02, something like that, and save that. So now I've saved these sections, I can load my views that I've played around with before. I can't remember what I called my views before, and it will bring back those sections that we've seen before. So annoyingly, this one's going to take a long time to plot. I'll just hit escape and hopefully that'll stop it. Okay, and that's brought back kind of this fancy pants section here. So view, load view. Okay, so you can quite easily switch between views that you've saved before, which is a really useful feature of almost any software package. If you can't save stuff as you're working, then bad times. So hopefully this has been useful. So you should be able to plot sections. You should be able to plot sections on top of each other, next to each other. You could play around with the layout, but do think about the scales that you're using, both X and Y, but also the color scale as well. And we stop.